Welcome to sureshbhattclasses. We are solving question on quantitative aptitude topic H.C.F and l.c.m. All the topics of quantitative aptitude are useful for many competitive exams like SSC CGL, Bank PO, RRB, Railways, and many government job exams and job interviews. These topics of quantitative aptitude are also useful for many entrance exams like CAT, GRE, GMAT, SAT, ACT, and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are solving questions on H.C.F. Our question is, the sum of two numbers is 276 and their H.C.F is 23. How many pairs of such numbers are possible? The given options are option A 6, option B 2, option C 3, option D 4. Before solving this question, I request you to please subscribe to this channel. As the H.C.F is 23, therefore two numbers we can assume are 23x and 23y, and their sum given to us is 276. We take common 23 and this gives us 23 into x plus y equal to 276. 23 divides 276 for 12 times. This gives us x plus y equal to 12. If x plus y equal to 12, then pairs possible are 1 and 11, that is 1 plus 11 is 12, 2 and 10, because 2 plus 10 is 12, 3 and 9, as 3 plus 9 is 12, 4 and 8, as 4 plus 8 is 12, 5 and 7, as 5 plus 7 is 12, and 6 and 6. Out of these pairs, 2 and 10 is not possible because 2 and 10 are not co-prime number. 3 and 9 is not possible because 3 and 9 are not co-prime number. Similarly, 4 and 8 are not co-prime number, and 6 and 6 are the same numbers. So they are not also co-prime numbers. To be 23 as H.C.F, the pair must be of co-prime numbers, and the two pairs which are co-prime numbers are 1 and 11 and 5 and 7. 1 and 11 and 5 and 7, these are the two pairs which are possible to have their sum as 276 and their H.C.F 23. Therefore, from the given options, our answer is option B 2, and those two pairs are 1 and 11 and 5 and 7. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, the sum of two numbers is 435 and their H.C.F is 29. How many pairs of such numbers are possible? The given options are option A 5, option B 7, option C 3, option D 4. Before solving this question, I request you to please subscribe to this channel. As the H.C.F is 29, then the number we can assume are 29x and 29y. And it's given that their sum is 435. Therefore, 29x plus 29y equal to 435. We take common 29 and we get 29 multiplied by x plus y equal to 435. 29 cancels 435 for 15 times. This gives us x plus y equal to 15. Now For being x plus y equal to 15, we can make the pairs of x and y. These pairs can be 1 plus 14 equal to 15, 2 plus 13 equal to 15, 3 plus 12 equal to 15, 4 plus 11 equal to 15, 5 plus 10 equal to 15, 6 plus 9 equal to 15, 7 plus 8 equal to 15, and then the numbers will repeat 8 plus 7, 9 plus 6. So these are the possible pairs of x plus y equal to 15. Now the co-prime pairs are 1 and 14, 2 and 13, 3 and 12 are not co-prime numbers, 4 and 11 are co-prime, 5 and 10 are not co-prime, 6 and 9 are not co-prime, 7 and 8 are co-prime numbers. So how many co-prime pairs are there? 1 and 14, 2 and 13, 4 and 11, 7 and 8. Then only the H.C.F 29 is possible, and the sum will be 4 and 35. So 4 pairs are possible. And from the given options, our answer is option D, number of pairs equal to 4. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the number of pairs between 30 and 100 having their H.C.F equal to 18. The given options are option A 3, option B 4, option C 5, option D 6. Before solving this question, I request you to please subscribe to this channel. As the H.C.F given to us is 18, so the numbers between 30 and 100, multiple of 18 are 36, 54, 72 and 90. These are the 4 numbers which are multiple of 18 between 30 and 100. Now we make pairs of these numbers. So one pair is 36, 54. Second pair is 36, 72. The third pair is 36, 90. The fourth pair is 54, 72, 54, 90 is fifth pair. And the sixth pair is 72, 90. Now these are the 6 pairs possible of numbers between 30 and 100 being multiple of 18. But 18 is not necessarily the H.C.F of all these 6 pairs. 36 and 54 have their H.C.F 18. 36 and 72 does not have their H.C.F 18. Instead, 36 is the H.C.F of 36 and 72, as 72 is multiple of 36. Now 36 and 90 have their H.C.F 18. 54 and 72 have their H.C.F 18. 54 and 90 have their H.C.F 18, and 72 and 90 have their H.C.F 18. So the 3654, 3690, 5472, 5490 and 7290 are those pairs which have their H.C.F 18, and these numbers are in between 30 and 100. So there are 5 such pairs possible, and from the given options our answer is option C, 5 pairs of the numbers between 30 and 100 are possible whose H.C.F is equal to 18. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, 3 barrels contain 592 liters of soybean oil, 703 liters of sunflower oil, and 851 liters of cottonseed oil. Find the capacity in liters of equal sized largest jars in which these oils can be packed without mixing. The given options are option A 19, option B 16, option C 31, option D 37. Before solving this question, I request you to please subscribe to this channel. In this question, we have just to find the H.C.F of 592, 703 and 851. We will find the H.C.F by division method. We divide 851 by 703. 703 divides 851 for one time. 851 minus 703 is 148. Now we divide 703 by 148. 148 divides 703 for 4 times. 4 times 148 is 592. On subtracting 592 from 703, we get 111. Now we divide 148 by 111. It divides it for one time. On subtracting 111 from 148, we get 37. Now we divide 111 by 37, and 37 divides 111 for 3 times. 3 times 37 is 111. On subtracting, we get remainder 0. The last divisor is 37, which is the H.C.F of 703 and 851. Now we divide the third number 592 by 37. 1 time 37 is 37. 59 minus 37 is 22. We carry 2. 37 divides 222 for 6 times, and 6 times 37 is 222. Our remainder is 0. It means that the H.C.F of 592, 703 and 851 is 37. From the given options, our answer is option D, 37 liters. And that is the capacity of the largest jar required for packing these oils. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, there are 3 co-prime numbers. The product of first 2 numbers is 589 and last 2 numbers is 1333. What is the sum of these 3 co-prime numbers? The given options are option A 101, option B 85, option C 93, option D 95. Before solving this question, I request you to please subscribe to this channel. Let the numbers be A, B and C, and these are co-prime numbers, and it's given that A multiplied by B equal to 589 and B multiplied by C equal to 1333. As A, B and C are co-prime numbers, and in these 2 products AB is 589 and BC is 1333. Here the H.C.F of these 2 numbers must be B, as A, B and C are co-prime numbers, and B is common in A multiplied by B and B multiplied by C. So we can easily find the value of B by finding the H.C.F of 589 and 1333. We will find it by division method. 589 divides 1333 for 2 times. 2 multiplied by 589 is 1178. 1178. On subtracting 1178 from 1333, we get 155. Now we divide 589 by 155. 155 divides 589 for 3 times. 3 times 155 is 465. On subtracting 465 from 589, we get 124. Now we divide 155 by 124. 124 divides 155 for 1 time. On subtracting 124 from 155, we get 31. Now we divide 124 by 31. 31 divides 124 for 4 times. 4 times 31 is 124. And the remainder is 0. The last divisor 31 is the H.C.F of 589 and 1333, and that is the value of B. Therefore B equal to 31. A equal to 589 divided by 31. This is equal to 19. C equal to 1333 divided by 31. This is equal to 43. Therefore, the sum of these numbers is 19, which is the value of A, plus 31, which is the value of B, plus 43, which is the value of C, equal to 19 plus 31 is 50, plus 43 is 93. So the sum of these 3 co-prime numbers is 93. And from the given options, our answer is option C, 93. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the number of workers among whom 1746 kgs of sugar, 2328 kgs of rice and 2813 kgs of wheat has to be distributed so that each worker gets maximum same quantity of sugar, maximum same quantity of rice and maximum same quantity of wheat. The given options are option A 79, option B 83, option C 91, option D 97. Before solving this question, I request you to please subscribe to this channel. The number of workers is nothing else but the H.C.F of 1746, 2328 and 2813, and we will find their H.C.F by division method. We divide 2328 by 1746. 1746 divides 2328 for 1 time. On subtracting 1746 from 2328, we get 582. Now we divide 1746 by 582. 582 divides 1746 for 3 times. 3 times 582 is 1746 and our remainder is 0. It means that 582 is the H.C.F of 1746 and 2328. Now we find the H.C.F of 582 and 2813. We divide 2813 by 582. 582 divides 2813 for 4 times. 4 times 582 is 2328. On subtracting, we get 485. Now we divide 582 by 485. 1 time 485 is 485. On subtracting 485 from 582, we get 97. Now we divide 485 by 97. 97 divides 485 for 5 times. 97 times 5 is 485. On subtracting, we get our remainder 0. Therefore, number of workers is 97. And from the given options, our answer is option D, 97 workers. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the greatest number which on dividing 1685 and 2075 leaves remainders 8 and 11 respectively. The given options are option A 123, option B 131, option C 193, option D 129. Before solving this question, I request you to please subscribe to this channel. We first subtract the given remainders from respective numbers. We subtract 8 from 1685 and this is equal to 1677, and we subtract 11 from 2075 and this is equal to 2064. Now we'll find the H.C.F of 1677 and 2064 by division method. We divide 2064 by 1677. It divides 2064 for one time. On subtracting 1677 from 2064, we get 387. Now we divide 1677 by 387. 387 divides 1677 for 4 times, and 4 times 387 is 1548. On subtracting, we get 129. Now we divide 387 by 129. This divides 387 for 3 times, and 3 times 129 is 387. On subtracting, we get the remainder 0. The last divisor is 129 and the required H.C.F is 129, or we can say 129 is that number which on dividing 1685 and 2075 leaves remainders 8 and 11 respectively. And from the given options, our answer is option D, 129. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the greatest possible length in centimeter which can be used to measure the lengths 6 meter 45 centimeter, 9 meter 3 centimeter and 12 meter 4 centimeter exactly. The given options are option A 31, option B 41, option C 43, option D 37. Before solving this question, I request you to please subscribe to this channel. We first convert all the lengths into centimeters and then we will find the H.C.F of these numbers by division method. 6 meter 45 centimeter is 645 centimeter. 9 meter 3 centimeter is 903 centimeter. And 12 meter 4 centimeter is 1204 centimeter. Now we will first divide 903 by 645. 645 divides 903 for one time. On subtracting 645 from 903, we get 258 as remainder. Now we divide 645 by 258. 258 divides 645 for 2 times. 2 times 258 is 516. On subtracting 516 from 645, we get 129. Now we divide 258 by 129. 129 divides 258 for 2 times and our remainder is 0. The last divisor is 129, which is the HCF of 649 and 903. Now we find the HCF of 129 and 1204. We divide 1204 by 129. 129 divides 1204 for 9 times. 9 times 129 is 1161. On subtracting 1161 from 1204, we get 43. Now we divide 129 by 43. 43 times 3 is 129, and on subtracting 129 from 129, our remainder is 0. The last divisor is 43, and 43 is the HCF of 645, 903 and 1204. And from the given options, our answer is option C, 43 centimeters. And 43 centimeter is that length which measures the lengths 6 meter 45 centimeter, 9 meter 3 centimeter and 12 meter 4 centimeter exactly. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the sum of digits of the greatest number that divides 7638, 5152 and 1423, leaving the same remainder in each case. The given options are option A 7, option B 8, option C 10, option D 9. Before solving this question, I request you to please subscribe to this channel. As the remainder is not given, so we subtract these 3 numbers taking 2 at a time. We first find the difference of 7638 minus 5152, and this is equal to 2486. Now we subtract 1423 from 7638 and we get 6215. Then we find the difference of 5152 and 1423, and this is equal to 3729. Now we have to find the HCF of 2486, 6215 and 3729. We find their HCF by division method. We divide 3729 by 2486. This divides for one time. 2486 times 1 is 2486. On subtracting 2486 from 3729, we get 1243. Now we divide 2486 by 1243. 1243 times 2 is 2486 and our remainder is 0. So the HCF of 2486 and 3729 is 1243. Now we will find the HCF of 1243 and 6215. We divide 6215 by 1243. 1243 divides 6215 for 5 times, and 5 times 1243 is 6215. On subtracting, our remainder is 0. So the HCF of these 3 numbers, 2486, 6215 and 3729, is 1243. And now we have to find the sum of the digits. So The sum of the digits is 1 plus 2 plus 4 plus 3 is 10. And from the given options, our answer is option C, 10. And that is the sum of the digits of the greatest number that divides 7,638, 5,152 and 1,423, leaving the same remainder in each case. I hope you have understood the method of solving such type of questions. Please do lot of practice from different books and solve as many questions as possible on topics of quantitative aptitude. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.